You are now muted.
Okay. We should probably start. Okay, first of all, Happy New Year, everyone. I hope you're doing great. Yeah. Okay, so I hope you caught up with the schedule during the holidays because it was over in an instant. So, yeah. So maybe I think today we will have a rather short one because we only have two questions, unless there's some problem with my mic and I have to fix it for 20 minutes. Otherwise, I think we will end early today. Okay. So let's maybe start. I mean, you know the question. Here it is. So we need to. We had this program that gives given a sequence of integers, it will compute up until the square root of that integer. Okay, and this is an exercise, is an somehow an extension of that. Here, we need to compute an output stream for the input stream. Okay, and I think I looked at it because I think Lars asked me before the Christmas holiday, and I didn't take care of it. After looking at it, it's not that hard, but I have to say that is whether something is easy or hard. That's always relative. I mean, for some groups, if you have a better understanding of it, you find it easy. But yeah, I don't know how to whether I should say it's hard or easy, or but at that point, I think you need to use fixed point semantics, and if you're not familiar with that, and that might be hard. Okay, so here's the solution. Okay, maybe let's start with something else that I would like to talk about. Let me have a look. Maybe I can share my screen. Wait, this slide, yeah. everybody see the screen? I think yes. Okay. So we have some nodes for the two languages. This init is continued by this one is default for Signal, and for Lustre, it's another set of nodes. Okay, let's first look what nodes or what characteristics do they have. Okay, so as you already know, we have this box value that on the synchronous level, it means that there is no value, but at the asynchronous level, it doesn't exist. Okay, and now on synchronous. I think I don't need to repeat that because that's you can watch the lecture videos. And here, let's take a look at these nodes. So first one, it is a con node. Okay, because this line doesn't mean that there are two rules. There is only one rule. And the first one is just initialization. Okay, that is a con node. For this one, this is also a con node because everything up here is initialization. And here, you can clearly see there are no overlapping rules because here A shouldn't equal to this value. Okay. And of course, there is no emptiness check. And it is also sequential because you can always read from A. Okay, fine. This one, also a con node because there is only one rule. This one also. This one, a con node. There are two rules here, but you can also read from here. And here A has to be box, and here it shouldn't be box. This is also a con node. Okay, so everything, these are all con nodes. Okay, what does that mean? It means that nodes are, or any composition using these nodes, they are what? Continuous, because each node is continuous and the composition of them is continuous. And what property do we have if node or a composition of node or the DPN is continuous? Then we can say that it is always prefix monotone. Okay, so let's maybe look back at the solution. So here we use default. I mean, this plus, this is not here we have a continued by. Okay, and these two nodes, they should be continuous. Okay, if we only use these two nodes, they should be continuous. But there is a plus here that makes it problematic, but I shouldn't dive into the detail here, but you can write something with plus that is not continuous. I just don't want to confuse you, but let me give you an example so that so you can write something like, let's use another variable, y equals to y plus 1. Okay, that one is not. Okay, that one actually has fixed point. That one, but that fixed point is not the one that you probably want. That one is the empty sequence for y. Because if y is an empty sequence, then this plus one cannot plus anything to it because the sequence is empty, and therefore, yeah, it is also a fixed point. But that's probably not the one that you want, and the one you want is not continuous. It's not will not converge. So here, but as long as you write something like z is equal to y plus 1, that is fine. Okay. We change the current value of a stream. That's basically what I want to talk about. And here we're not, because here this plus, it might be problematic because we have z here, and we also have z here, and we have a plus here. But this continued by, if you remember, it shifts the, maybe I should share my screen again. We're continued by, yeah, there is continued, but I see on what? Okay, here. So for x, it shifts the stream, y one place to the right. Okay, it's actually not using the current value of y, it's using the previous value of y. Okay, so that should be fine. Okay, so let's maybe work out what this will yield in the end. So maybe for those groups who got it right, some of you have bottom here or something else here. But if you bottom, that is not right. Why? Because then you have bottom at the first value, okay, and continued by a sequence of integers, and then plus one. One is a stream. Okay, so what is the first value then? You have bottom plus one. Okay, that shouldn't be the case. So it has to be an integer here. It can be, I think, anything, as long as you are not using bottom. Okay. So maybe for an example, you, oh, one, three, box. Okay, it's probably not a good example because I have too many boxes. Two box. Box I cannot write here because this is blocking me. Oh god. Let's delete. Okay. How can I fix this? Okay. Let's start over. Second try. N is 1, 3, 4, 5, 6, 7, 8, 9, and we have 2. Okay. So what is f of z? So let's assume that this whole thing is a function f because it's a composition of nodes, and n is known. Okay. 0 is of course known. 1 is also known. Okay. So it's actually a function on z. So um, F, so we are computing X point, by the way. We start with Z being the empty sequence. Okay. And here, Z is the empty sequence. 0 continued by Z basically means that we put 0 in front of any sequence. Okay. And shift it to. So 0 plus 1 is 1, but it's n default 1. So it's 1 because the first value of n is 1. Okay, then we can have. So we know it's prefix monotone, by the way. So it has to be 1 here. I mean, you can also do the equation again, but that's actually not necessary because we know it's prefix monotone, so it cannot be anything else. We can do it again to check. Maybe let's do that again. So 1 here for Z, and 0 continued by Z is 0, 1, right? And if we the it is now 1 and 2, but it's n default that, so it's 1, 3. Okay. Now we have 1, 3. It's 0 continued by Z, and now Z is this one, remember, because we're doing a fixed point iteration. And after applying the function, we get a Z, and we need to apply the function to Z again. It's 0, 1, 3 plus 1 is 1, 2, and 4, right? And if we have n default that, then it's 1, 3, 4. And okay, we can keep on doing that, but I'll just abbreviate that here. So we have 1, 3, 4. We shifted compute 0, 1, 3, 4 plus 1. Then it's 1, 2, 4, and 5. No, it's 0. Maybe I should. 0 continued by Z is 0, 1, 3, 4. Plus 1, it's 1, 2, 4, 5. Interesting. Then it's not right. It is. Then n default that. So it's 1, 3, 4, 5. Okay, I overlooked one. So we can keep on doing that. Then we reached here. And now we can do that again. But since you know that it's n default that, so here it will be 2 again. Because this is prefix monotone, this part will never change. Okay, and when we have here, we will go into the same situation as where we had 3 before. And so it will keep on computing. Okay? Is there any problem? Questions? No? By the way, also, I think I mentioned somewhere, this question mark means pure input, which means that you can only read. This exclamation mark means that it's a pure output, which means that you cannot read from it. You can only write to it. So what you have to do is, here you need to define a local variable, z, here. Notice that z doesn't have question mark or exclamation mark in front of it, which means that you can both read it from it, and then after computing that, then you send it to the output. I think that is also a question I think Lars' group has had. Okay, someone is still typing. I mean, the safest way to write this, an expression on the right, is to use the previous value. That's why we have pre in illustrator is continued by in signal. And actually, I prefer this continued by in signal to init, because this init will have problems. You might have a problem with, I don't know, um, having multiple fixed points, and you have to define clock consistency to strings of the program execute simultaneously or one after another. It's an equation system. So whenever you have an equation system, it means that you have to find the fixed point. So an equation system doesn't have a sequence. Okay? It's like a mix. You can shift one row down and one row up. That doesn't. So here you can also write the second line first. That's fine. By the way, in synchronous languages like quads, we also have equation systems at the end. I think you should probably know quads by now. And that one is also a fixed point. When I see an equation system, it basically means you have to find a fixed point for that. Any other questions? No? Okay. But you can write this down and maybe play around with it yourself. If you didn't, oh, I wrote. Okay, this one is also bit problematic, but that's not really a big deal, I think. So here we have a signal process, and we need to compute the clock consistency condition. And finally, we need to see if the process is clock consistent. Okay. First of all, just eyeballing it, what do you think? Is it clock consistent? It should be, right? Okay. Maybe I should also say something here. So let's go to where clock consistency is defined. Notice where the clock consistency is defined. It's not defined before we talk about these nodes. It's defined when we talk about arithmetic and logic operator. Okay. So everything before it does not have clock consistency problems. Because why? There you are allowed to have boxes on one side and not boxes on the other side. But for these operators, we don't allow it. Okay. Either both are boxes, or both have values. Okay. Now, let's look at this exercise again. Okay, this backslash shouldn't be here. Does this equation on this side have any arithmetic operator? No. The only one that is problematic might be this one, but we'll talk about that later. So a lot of you computed the clock consistency condition of the right-hand side, but the right-hand side is not the entire process. Okay, the entire process is O equal to this. So you have to compute the clock consistency condition for this one, for this entire line, and not only the right-hand side of this line. Okay. So as you can see here, it's the entire line we have to compute, because we have to compute CC and then program P. And the body of program P is this line, this whole line here, and not just the right-hand side of it. Okay, it's this one. Then what's the clock consistency condition of that? It's the clock of O. The clock on the left-hand side should be equivalent to the clock of the right-hand side. And I think I omitted something here. And the left side is consistent. Okay, any variable by itself, it is clock consistent. Here is 1. Okay, so that's why I omitted it. And then we have CC this part. Okay, so a lot of you only computed this part. The right-hand side of the conjunction, of this conjunction. But that's actually also not incorrect, but I'll explain later. So but that is not the clock consistency condition. So here we have this one and this one. And we can keep on doing this. The clock of that, what is the clock of that? The clock of when is the clock of the first one and when B is equivalent to 1. You can check the definition. Okay. And here, this should also be clock consistent. But here we do not require the clock of this is equal to the clock of that, because 1 is not an arithmetic operator. So only the left-hand side is clock consistent and the right-hand side is clock consistent. So we have CC this part and CCB, and this one is true because clock consistency condition of a single a stream by itself has no clock consistency problems. So this one is fine. And then we have this part here because the clock of n init 0 is the clock of n. And here it's B, equivalent to 1. And here we have the same, this dollar init sign doesn't have, it's not an arithmetic operator. So we need to only ensure the left-hand side, which is CCN, is clock consistent, and CC0 is clock consistent. This one is true. This one is again true. And now we have that one here. Okay. So that one is finally the clock consistency condition. So any questions up until here? I think I explained it rather clearly, but you might still have no. So it's clear. Okay. But let me add a few things here. So for when here, we need to still compute the clock consistency condition here, because this thing might still have an arithmetic operator inside. Okay. So if this would be m plus something, that's due to compute clock consistency condition, because we can see, yeah, it doesn't have an arithmetic a logic operator, but yeah, if you do that recursively, this has to be here. Okay, and now the problematic part. So looking from this side, it should not be clock consistent, always clock consistent, but we just discussed that this problem, this program doesn't have clock consistency issues. So why? So here is the thing. Whenever you have this equation here, you can think of it as also as an binary operator. Okay, first of all, think of it like a binary operator, just like plus or anything else. Okay, and after that, this the compiler asserts that this is valid, but only for this operator here, because the clock on the right hand side should equal to the clock on the left hand side. Okay, so it asserts that this equation here, I hope you can see me. Oh, am I not the presenter? Okay. Um, search that then is valid. Flock of one side is equal to the block of left hand. So which means that this whole part here is already valid, which means this whole part is all true. So whatever you get, because this one is simple, as we know, this C here, we have computed here, here, here. It's equal to true. So what we have here is actually a simplification of this one. Clock is equivalent to log of 1. So it is still equivalent. So this, what we get here is equivalent to what we have here. But we assert this is valid, this is also valid. So C is true. And I can also maybe point you to the slide. Here's one that he might have neglected. I don't know what it is. It's here. The equation asserts that the clock of x equal to the of the left side equal to the right hand side. And as you can see here, we also need to consider here. You see, we need to consider first need to see the the quality here as arithmetic operator, like we did here. We need to ensure that 1 is equal to sigma. And of course, y by itself is constant. It's not written here. And the expression on the left should be clock constant. So first of all, you assume this one is, and then after that, this is the whole thing true. Okay, I hope I cleared it up. And there's one more question. If there is multiple solutions, there is only one. Because, I mean, solution really happen when you have a recursive, or I say that, recursive, like we have here, set depends self, that might have problems because we might have multiple points. Then we need to define clock consistent condition to pin down to one solution. But do we have that here? I don't know. We don't have any recursive definition here. We have O, but O doesn't appear on the right hand side. So for those who said this multiple equation, there are multiple things, but oh god. Is it bad for everyone? Let me log that. Okay, I hope it's better now. So where did you lose me? I should probably repeat what I got for. I probably repeat the whole thing. Yeah, one solution. Okay, so the the only situation where it might be problematic and have multiple solutions is when we have these equations that depend, so like depends. So we need to compute the fixed point, right? And then when we are computing the fixed point in signal, we might run into multiple solutions, and we need to narrow down the solution to one by defining a clock constraint. Okay, but do we have that here? We don't have that here because O does not appear on the right-hand side. So, so on the it's just from input to output. There is no fixed point iteration, and for so I don't know, for some groups that there might be multiple solutions, and I don't understand. Maybe I understood you wrong, but there shouldn't be. Because what does that mean? It means that given a stream N and B, if you what you said was true, then you can have multiple O's. But then you cannot finish 3 and 4. Because for 3 and 4, you're given an N and a B. If multiple solutions for O, how did you compute that? I was confused. It was just the point where you didn't understand it anymore. Uh, okay. Oh, okay. Okay. I think it's fine here. And for this, I don't have anything to say. It is what you, all groups got that right. So well, when these kind of questions appear in the exam, you have points for free. Grab them. Okay. And I think that completes this week's exercise, or the last exercise. So further questions regarding next week's exercise? Or by the way, I strongly recommend you to have a look at the exam, because in exams, a looser program might still appear. And there you need to know, by the way, this is also related to this denotational semantics, if you remember, because there we also need to compute fixed point. Actually, it's the same thing. And here, N, B, and O's, they are streams, so actually it is stream function, so it's basically the same thing. No questions? Then we could end early today. Does anyone object to that? Oh, I need something, right? So, let me check. Nearly forgot. Um, let me check in the. I have in the chat somewhere. So, last time people were asking about the exam date. Okay, and for the instance, do you know when you will be back? Do you have any idea? Hello? So this might be relevant to all of you. So do you know when you will be back? Because last time you said that you don't. Was it because of my mic or you didn't get it? I don't know. Back to Russia because it's the exam that we're talking about. I thought you wanted the exam date to be shifted. So what we're doing, um, does any one of you, what is the current date? Yeah, but that's not precise enough. You cannot say approximately because I have 3 dates here. Yeah, that current exam date is 6th. Okay. Okay, thanks, Philip. So we have 3 dates here. So to all of you. Okay, to all of you. We have 3 dates here in March that we would like to shift to, namely the 23rd of March, the 24th of March, or the 25th of March. Okay. And the reason for doing that, because of the Russian students who we have a collaboration with, and they need to be back before April. And so here's the thing. If any of you, by any of you, I mean people other than the Russian students, if you have a problem with shifting it early, then you can tell us. Then the exam date will be kept. It will be kept to the 6th of April. Okay, and they will take the exam in Russia. And if none of you have any problem with shifting it to one of these 3 dates, then we will do it. By the way, I will also write that in the news section. So if any of you have a problem with that, either because of, okay, it's a clash with another one of my exams or whatever, I just don't feel like taking the exam that early, yeah, then you could say that. And it will be kept. Okay, but for Jonas, you have an oral exam on March the 23rd. So I assume that you're saying that the dates on 24th and 25th are also not good for you. Yeah, but I also feel bad if I make it on the 24th or the 25th because, and I can also assume that other students might have problems. But anyway, I will post it in the news section. If you can write to me, reply to me if you have potential concerns, like Jonas here. Okay, even if he has, yeah, I don't know. At this point, I should already say that we should keep it. Yeah, then it's. I think the last time the students took the exam in Russia, and that worked out fine. Okay, someone else. I actually said something before. 25th of March is bad for us. Okay, then there's no way around it. Okay. Okay. Then let's keep it. Let's keep it. Okay, then I think I will to post that because it's pointless. Okay. So that's all from my side. If there are no further questions, we can end here. So for all of you for those of you that are unclear, the exam will be kept. I think that's maybe the best way. Kept on April the 6th. I should make that explicit. because I think people normally don't have don't have problem with delaying the exam, but yeah, making it earlier, yeah, it's always not so good. So let me make sure. So, does any one of you have questions? I think no. What? Yeah, but that I think we cannot work around because the exam is, if you have a clash there, then if you feel uncomfortable with that, then you could also always choose the next exam. That we cannot, because that's also how it worked back then. If you have two exams on two consecutive days, then yeah, you need to choose one of them. If you you have a hard time managing them both at the same time. By the way, you can speak. Are they in the same group? I think they're two different groups, but I can ask about that. What is PAES, by the way? Sorry for asking. Power aware embedded systems. I don't think they are in the same group. I think that one is from. Um, I don't remember, but it's not from Professor Bounce. They are not in the same group. So why are you saying that? Yeah, No, it is not. I mean, if we have to take care of exams in other departments or other groups, then that is really not our job, because um, you could. That's your decision to choose both of them at the same time. I mean, there are students who didn't choose that. I mean, even if they are in the same group, let's say that they are in the same group and they are on 2 dates. I don't know if the exam dates are published at the beginning. Then it's if they are published in the beginning, then it's your decision. I mean, you if you chose 2 lectures at the same time and that have the same time slot, then and it's also not the case that you cannot have close dates for exams within a group, because, for example, I can have in our group, I think we have this Digitaltechnik und Rechnerarchitektur. And another one is Rechnerorganisation und Systemsoftware. Okay, this one is, I think, back then, I don't remember the name. Yeah, computer systems 1 and 2. Okay, that are in different 2 semesters. And they can be close to each other. The dates can be close to each other, because why would anyone take both of them in the same semester? Yeah, but that's that's something else that I don't want to deepen here, because that's always a problem. So organizing this is always have a lot of problems. Okay, for those of you who don't have further questions, you can already leave. Okay, I think that's okay. I think we shouldn't waste everybody's time here, because I think everything is set in stone. Okay, then wish you a nice weekend and see you next week. Good luck with the exercise. Okay, bye.